Alright, this is our second video doing HTML and CSS, and the goal is to cover at least an example of each of the items here. I have an HTML file already prepared that we'll put some style on. The file is here in our class directory. It is styled to bases. So here we're going to be looking at binary, converting binary to decimal and decimal to binary. It is important that you understand the bases. It matters for a variety of reasons. So just to quickly look at these two examples. So if you're going to convert from binary to decimal, here is a binary number. That means ones and zeros. And the way binary works is the first bit is worth 1 if it's there. The second bit is worth 2. The next bit is worth 4. And the next bit is worth 8. And they just keep going up by 2's. So I have it here in a table. This number here, this is the 1's bit, the 2's bit, the 4's bit, the 8's bit. And the rule is if there's a 1, then you add the value. So we'd have 1 plus 4 plus 8. This number here would be 13. Let's go ahead and put another example in. Maybe something that's a little bit longer. I'll start with this one. And maybe we'll go with something that is 6 bits long. So 1011, that's 4 bits, and then maybe 10. Okay, so if I want to duplicate what I had here, then there are going to be 2 more cells. And I want to put just the binary values in there. So I have a 1, and then a 0, and then 3 ones in a row, and a 0. And originally I had 1's bit, 2's bit, 4's bit, 8. The next one would be worth 16, so I need to put that in. I'm calling it 16's bit to mimic the way we talk about base 10 in the United States anyway. The next bit would be worth 32. That would be the 32's bit. And I'll leave these blank for now. We'll go through the example. Alright, let's take a look at this now. Here's our example 101, 110, 101, 110. So we have the 1's bit, the 2's bit, the 4's, the 8's, the 16's, and the 32's. So here I would just want to write in the positions where there's a 1, I take that value. So I do have a 1 on the 32's bit. And then the 8's, the 4's, and the 2's, I skip over the 16's bit. And I also don't have on the end. So I'd have 32. The rule is the ones that are 1, you take them and then you add them up. So I'd have 32 plus 8 plus 4 plus 2. Plus 8 plus 4 plus 2, which equals 46. I added them correctly. Alright, that is converting binary to decimal. And let's go ahead and put some style on this to make it look a little bit nicer. And let's give we'll go ahead and put it here for now. Okay, so in the head section, if we want to keep this in the HTML file, we can have a style section. So here I will do the H2 headings just to give an example. So color, I'll do maroon again. And maybe text. I want to be centered. There they are, centered. And let's just take a look at the different properties. So background, color, font. If I want to change the font, then I would probably do that on the entire file. Let's take a look at, if I inspect element, let's see. Right, there are different things I can do with the font. So I can do font. Here I'll get a list of the ones that Firefox understands. So font size is the size. Font family is the actual font. And there are fonts that are built in. And I could also say something like serif or sans serif. Converting between bases, so we could see that change there when I had serif, when I had sans serif. So sans serif looks better on a computer screen than a serif does. I'll go ahead and use that for my entire body. Font family, sans serif. So that doesn't say the exact font to use. It just says to use a sans serif font, which means it doesn't have the little extra decorations on the characters. Alright, that's font family. If I want to play with the size, I could. We'll leave that. We have color, background color maybe for the entire body, or we could do it per section again. So I'll do the algorithm. I'll call this, so I don't want to necessarily give every paragraph a certain background color, but I'll call this a class equals a section. So anything that's a section, I'll go ahead and give it a background color of light gray. Don't need quotes there. Okay, and I will give it also a padding of 10 pixels. And I probably also should do the same for my algorithm down here. So this is a section. Okay. If I want to have my examples also, then I would need to have a tag around them. So I will call this a section. So that entire, everything that's inside of that division will be with the same background. And I'll go ahead and do that on my decimal to binary, which we'll talk about in a minute. Okay. some issue down here with class equals. Alright, so we have our background color. Now let's take a look at this table and see if we want to do something there. One thing we can do is put some extra padding in. Let's look at, we have a couple of things that we're supposed to do with tables. So for a table, there's border collapse and border spacing. Why don't we put a border on the table? Table, and then we would say border equal 1. So that puts a border around every cell. The border collapse, why don't I call this a table, and I'll give it a class which is, I'll call it an example class. So any table that is an example, border collapse is something. And if I don't remember, let's go ahead and inspect the element. My table here, border collapse, and those are my possible options there. I'll say collapse, and then I'll go ahead and put that in here as well. Okay, so that collapses the border inside of there. We can see that. Now border spacing, let's see what that looks like. Border spacing. So that is not a value. Let's go ahead and see what they say inside of the table. HTML tables. Okay. So if we look over here, right, the border spacing is, so if we take off this border collapse, then the border spacing would have an effect. I probably don't want to use that. Let's put a margin in. We don't want to put the margin on the table, we'll put margin inside the cells. So this would be inside of the TD. We'll have a margin of 10 pixels. Or let's try padding. I don't think we'll talk about margin and padding yet here. The difference in a table, so let's go ahead and put some space in there to make it look better. Okay, maybe we want this top row to be highlighted. So if we want to do that, we can say that the top row is going to be maybe we'll call it highlight. So here we'll say dot highlight. So anything that we decide to highlight, maybe we'll decide that the color is going to be we'll have to decide. Why don't we go with just gray. And if we don't like the color being black of the text, then we could make it perhaps white and font weight as bold. Okay, you'll notice the border inside of there is also white. Okay, now if we want this table to have the same, we need to give the same options here. So border equals 1 is what we did. Class equals example. And here we had highlight. And if we wanted that to happen down here, then we would do the same. Now if we're doing this for every single table, then instead of using the class, we would just have it as the table. Okay, there we go. Now suppose that we want the first column here to be in italics. Okay, there's different ways to do that. One is that we could have a class on the first TD here, or an ID on the first TD here, and specify those all to be italics. Another way would be to use the first child selector. Alright, so this is something different, that if we say tr first child, this will be the first child of the row. We want to make it italics, whatever the italics was. We did that in the last style 1. Font style, okay. Let's see if that works here. So now we see that that row there is italics. So that's the first row. So what we really want is the TD. That is the first child in the row. It's loading here. Okay, so now we see each of the first children are italics. And that's true in this table. It's also true in this table. Now, what is the difference between, so we see that the spacing here looks sort of okay. Here it doesn't. If we go back and look at the element here, so this is a TD, and we can look at what is being done. So we have a TD, and the padding on a TD is 10 pixels. So now we could look at this one, and that's actually a TH, which can be used in place of a TD and a header, and it does some different style automatically. So I could change, if I want the spacing to happen here, I could change this to a TD, or I could go in and whatever I do to a TD, I could also do to a TH. And in the list here, so the way these rules are read, you have a selector and then a set of rules, set of properties and values. The selector can be just the name of a tag, and it'll do all tags by that name. It could have a class, it could have an ID, and you can also specify multiple selectors just by having a comma. So now I did the same rule with the TH. Let's put some links in here to see what we can do with the links. Convert binary to decimal. Let's pretend that this is a good place to go to. Okay, if that's the case, why don't we go down here to the bottom and we'll do an H2, more information, H2, and we'll do it like this. So we have an A tag. What was this supposed to be? Binary to decimal. And you need to remember that you don't want to put a greater than there, so that should be GT, because greater than has a special meaning. So here I have this link. Now, if I don't like that link being purple sometimes, I can specify in my style here. Now my style is getting kind of long, so I think I'm going to actually separate this out. So we had a link rel equals style sheet, and then we give the href style2 bases.html. And this is the preferred way to do things, so I'm actually going to put all this over into the style sheet. So now I need a file called style2. It doesn't have to have the same first part. It can be anything. And then I don't need this style tag. This is nice because the HTML file now just has information about the content, and all the styles, the formatting, goes into the CSS. Go ahead and tab this all. Okay. Now, if I don't want that link to be a different color when it's visited, there's a special thing called a visited. So I can say a visited or a, either way. I'm going to call this color blue. Right. Alright, so there's the blue. And if I don't like the underline, then I can say text decoration none. That gets rid of the underline on the tag. Now, whether I visit it or not, the color is blue. Now, if I want a different color when I hover, I could say a hover. Color maybe red. have to reload. Now when I hover, it changes color. Okay, so that tells somebody that it's a link. I believe you can also have a different color while you're clicking. Okay, why don't we put some more links in here? So we'll have decimal to binary. Different website. So let's pretend that this is a good link. It may be. I haven't looked at it. So this is decimal to binary. There we go. Now if I want to have this behave differently, there's a few things that I can do specifically with lists, which are listed in our notes here. For lists, we have list style type. So list style type, I believe circle is a choice. Let's see if it works. So there's a circle, that's instead of a disk. If I want to see what the options are that Firefox thinks, then I can go here, list style type. Tell me the options. You can also do square if you like squares. So circle, square, and disk are the standard ones that all browsers should be able to do. And if I say none, then there's no disk or anything there at all. I'll leave it as circle for now. Alright. Width and height, we should do something with. Text align, it can be right, center, or left. So if we wanted the last column here to be right aligned, there's no reason we would do that. Let's make everything that by default put these in the center. That's normally good for tables. Okay. Let's see, we're supposed to look at the width and the height. So for any element, we can say what the width or the height is going to be. If we want this, say we want this table to be the same width as this one, we could tell it, and let's use, let's just say that we want our example table. We could say width, and we can give a pixel value, 500 pixels, and so that'll set them all to be 500 pixels unless they need more. If they need more, they'll grow wider. Or we could set them to 50%. So if I shrink this, then they shrink, right, until they can't shrink anymore. So doing 500 pixels here is kind of reasonable. They'll all kind of line up. It's nice. Now, how would we make it so that this all goes over to the right? We would have to have, we can play with it here. So if I want to take the entire table and put it on the right side, then what I would be thinking is that this actually would be right aligned. That's the thing inside of it. And that moved one thing but not another. Alright, let's leave that for now. We have lists, tables, width. So width we can give percentage or pixels, same for height. Padding and margin, let's just briefly say something about the padding versus the margin. So if I'll look at this element here, the best way to look at this is here. So we have the element itself, and then padding, and then outside of the padding we have a border, and outside of the border we have a margin. Let's go ahead and put on the algorithm here so we can see this. So the algorithm was a dot section, so we'll do padding of that, margin of say 5 pixels, and a border of say 5 pixels solid yellow. Okay, now we'll look up at this section here. So if we look at this section here, I believe that's the algorithm. Let's see. No, we're binary to decimal. Right, I can't really see it highlighting. I think it's highlighting in yellow. But if we look at what it says here, the actual content is this dimensions. And then we have 10 pixels of padding. It changed it to 4.5 pixels border, and then a margin of 5. So what if I change this margin to be, say, 15? What part of that is going to change? So you can see it's changing the white space. And if I change the border, that's the border. If I change the margin, say it changes to 20. So the margin will have the same background as this. And then you have a border, and then the padding will have the same background, and then you have the border, and then the margin will be like outside in terms of the background. So this mostly the distinction between these is in terms of what background you want things to have. Okay, border collapse and border spacing we have, list style type, text decoration we have for the A tag. So we've done all of this basic stuff. There's a lot more things that we could do here. I think that'll be, let's take a pause. Okay, so there are two other things. One is we want to look at this, go ahead and look at this real quick, decimal to binary, how is that done? And also the answer to the quiz question for watching this video. So if you're watching this video and you're actually listening to it, the quiz question is going to be P stands for. What does P stand for? The letter P, and the answer will be polynomial time. Polynomial is one word. Polynomial time. That'll be your answer. Alright. Now, let's take a look at this converting decimal to binary. So the algorithm is listed here, what you're supposed to do, but let's go through the example. So we have a number 42 that I want to convert into binary. So the rule says you just need to know whether it's even or odd. 42 is even, and that means the last bit in the binary for 42 is going to be 0. Okay, so then we divide 42 by 2. That's just what we're supposed to do. That's 21, and then we look at 21. 21 is odd, so that means if we're looking at 21, its last bit would be 1, and I write that down. Now I divide 21 by 2, and I get 10 with rounding down. Okay? Now looking at 10, as a binary number, its last bit is going to be 0 because it's even. And then I divide 10 by 2. 10 over 2 is 5. Now I just want to look at 5. What is the last bit of 5 as a binary number? It's odd, so the last bit is 1. And you could probably already write the binary representation of 5, or at least a lot of you could. It's going to end up being 101. So 101 is right here in the answer. If we go back to the binary, if we were just looking at 101 here, and this was the 1s bit, the 2s, and the 4s, this would mean 4 plus 1 is 5. Okay, and it'll work out that way by doing this. The last bit of 5 is a 1. Divide 5 by 2 and round down. You get 2. 2 is even. That means its last bit is going to be a 0. 2 divided by 1 is 1. 1 is odd. There's only one bit there, and it's a 1. Now, all the bits that we wrote down, we had the last bit of 42 is a 0. The last bit in 21 would be a 1. The last bit in 10 would be a 0. The last bit in 5 would be a 1, and so on. And so we wrote all these down, and if you can actually show that this actually is the binary representation in reverse. So the binary for 42 is 101010. Let's do another example that we'll put in here. So I'm going to do a whole nother div that's another example. Alright, so let's take another number, maybe we'll take 37. Okay, so now I'm going to take 37, I'm going to take out the rest of the numbers here, and we'll have to fill them in as we go. At this point in time, you could pause the video and fill this out on your own and see if you get the right answer, and then when you see that you're doing something different than I am, then you want to pay attention. Alright. Okay, we have another example here. So 37, we just need to say whether it's even or odd. It's odd. That means its last bit is going to be a 1. And then the next thing we're going to look at is 37 over 2 rounded down. That should be 18. So here I should have odd, a 1, and the next number would be 18, which we would put down here. Okay, 18 is even. We put a 0 for being even, and the next number is 9. Even, 0, and 9. Okay, so then we put a 9 down here. 9 is odd. That means we write a 1, and the next 9 over 2 is 4 after you round down. That means 4 is the next number here to look at. 4 is even. We put down a 0. The next number is 2 to look at. Two is even. That means we write down a 0, and the next thing to look at is 1, and 1 is where we always end up in the end. We keep dividing by 2 until we get to 1. and then when we get to 1 we would be done, and then we'll be able to read off the bits of 37 in binary. So 37 in binary should be 100101. And now to check your work, you would take this and convert that back to decimal and see if you get the right answer. So this would be the 1s bit, the 2s, the 4s, the 8s, 16, and 32. So we'd have a 32 plus 4 plus 1. (34) plus 2, 32 plus 4 is 36, plus 1 is 37. So that's the right answer. Okay, we'll say that is enough for this video.